right, everybody. Welcome to my presentation here, which is modeling OpenStack and oVirt. My name is Paul Gambardello, and I'm a specialist solution architect from the Cloud Infrastructure Attacker team here at Red Hat. So what we have today is OpenStack and oVirt. OpenStack, in my opinion, needs a sidekick. OpenStack just can't do everything itself. We would love for it to do it, but it really can't. It needs some other things that will have to exist outside of your stack deploy. Things, like a DNS server, maybe a repository, something, anything. We always have these dependencies, these infrastructure pieces that don't necessarily belong inside of OpenStack, but are complementary to it, maybe like a satellite server. So what is oVirt? oVirt's a virtualization solution. It manages KVM hypervisors. KVM is the same technology that is in the hypervisor in OpenStack, but this is just a different implementation of it. It's the upstream to Red Hat's product, which is called Red. It's very simple to operate. It's all GUI. And it can be used to supply a virtual control plane to OpenStack, which begs the question, why? Why do I need 3 servers for my control plane? For my controllers. When I do H8 controllers in OpenStack, that's eating some hardware. Customers hate it. I hate it too sometimes because it can be kind of a waste, especially when a customer has bought the same hardware across the board. You have pieces of hardware that are just as big as their compute nodes serving as controller nodes. It's not exactly the best role. So we can use it to minimize their footprint. So what is the virtual control plane? It's basically a way for us to take the controllers and put them on top of Rev, along with your director, and maybe anything else that might be complementary to your stack. It can expose the OpenStack private networks to VMs inside of oVirt, which lets you do cool little tricks. Like, for instance, if you do perhaps like a very minimal deploy of OpenStack, where you just have one flat network, this will let you jam little things in there, like say a repository. I could put an offline RPM repository in there, sew in the repo into my deploy image, so that when my machines get deployed, since all machines always have access to the control plane network, they'll always have access to that. So I don't even need to bring in anything. I can do the simplest possible implementations and build them all the way up. And it lets you easily snapshot things. That's another consequence of virtualization. If I snapshot my controllers and I do something dumb, then I can roll them back. The same thing with my director, right? It also provides a place outside of OpenStack to host other things, as I said before. So how does this help you, right? The virtualized control plane's been around since OSP 13. We released the driver. The driver's called the oVirt staging driver. And they have an implementation of this. We're going to do that, but this time we're going to do it harder. We're going to do it better. Because it has some limitations, and these are ways that we can get around some of these limitations to do better things. So the goals for this are to model OpenStack deployments, from the simplest thing all the way up to really complex things. It'll also allow us to quickly iterate things. We know that as we work on templates and different things or try different features, things can, it can take some time to do a deployment, especially on real hardware, and rolling it back and going through that process over and over again. In this way, we can not only just have one stack, we can have many stacks to beat on at the same time, try different changes. And we can also do this in a way that doesn't affect our maybe production stack or the thing that's on the real hardware. We can try updates and deploys and all sorts of other things before. Test new services and OpenStack releases. Well, OSP 14 is out now, and that's what I have rolling on my lab, trying this out here. You may or may not be aware, but this week is OpenStack 14 Hackfest for us here. For us here at OpenStack, for those of us that work with OpenStack here at Red Hat. At least some of us, and we get together and kind of do use cases and things, like just try to make sure that it's all good. Kind of like when you first get a video game, you buy it, plop it in there, and it's got to download that day 1 patch. Well, this is kind of the day 1 patch for OSP 14. It's just coming. We're working on it right now. Of course, external application integration. If you want to do IDM, maybe you want to do some ironic bare metal. Maybe you want to tie it into some open contrail or some other kind of machine. Do that. So how are we going to accomplish all this? We're going to bring out oVirt's bag of tricks, and we're going to do some things that are not normally done in oVirt today, but I want to make them a little bit more popular by showing them off. So we're going to use nested KVM and the oVirt staging driver to virtualize compute nodes. Right? Now this is not supported. I'll make a big disclaimer. None of it, like anything beyond your controllers is not supported. So this is just purely for the purposes of modeling and testing. We're also going to use the staging driver in Ironic, and we can also use that to provide bare metal targets for Ironic inside of oVirt, which is cool. We can also test that. We're going to use SRIOB to pass trunk ports to OpenStack nodes. And this becomes a little important. I'll get into a little bit more of an explanation about how and the why for that. But just know that this is a big part of us coming over some of the initial hurdles that were present in the implementation of the virtualized control plane. We're also going to use host PCI pass-through. We can also use host PCI pass-through to give physical disks to OpenStack nodes. So what does that mean? What if I want to model something like an HCI deployment? I can give those things virtual disks and use them, but it's not going to deploy that fast, and it may not be so realistic to real life. Or maybe I want to deploy Ceph in a virtual fashion. If I can roll up to my machines and jam in some commodity SSDs and then use PCI pass-through to hand them to the guests, it's just like that virtual machine has a real hard drive and can perform as such. It's kind of cool. So what does OpenStack get out of all these things, right, that it doesn't already get? Because the virtualized control plane already exists. Well, now we can use these little tricks and tools to model our deployed OpenStack right inside the virtual control plane. So it's kind of like a 2-for-1. You've already virtualized your physical controllers, right, and you still have physical compute nodes. But now you can have an entire little mini virtual environment for you to test templates and upgrades, things of that nature. Because everything's virtual, I can also create virtual storage backends, from various different things. We can use this to model Gluster, Ceph, iSCSI, NFS. I don't really know how to like virtual fiber channel, but if I ever figure that out, I'll let you know. We could also do really complex things like modeling networking topologies like spine leaf. Again, pass real disks to physical instances. Model multiple site deployments, things like federation, keystone federation, or DR. Failover. You have your workloads up there, you can have little test instances of your workload and test those kinds of things. Or I'm testing Ironic again. Much more. So, welcome to my home lab. This thing is a little ridiculous. I am neither smart nor money, but I tried to throw both of them at this thing to make it work. It's very much a work in progress. Just this past month, I upgraded this whole shebang from InfiniBand to 10 gig. As I said, I'm neither smart nor money, so I started with InfiniBand, right? I wanted to switch to 10 gig networking for my home lab to get my hands on SRIOB so that I could start bringing that technology to VMs and let VMs use that. My home lab is 4 DL580s. They comprise 160 cores and a terabyte of RAM. We also run Gluster. Gluster has 100 terabytes of raw storage. As I said, for insert money to build dreams, that seems to be the name of the game here. So we're going to go take a quick look at what it is. So I'm going to get out of my little tour here, and we're going to go look at Red. And the OpenStacks contained within.
Make it a little bigger?
Yep, I'm going to try to work on it. Anyway, here's just a very long list of virtual machines that are in here, but I wanted to talk about, first of all, doing virtual OpenStack inside of here, and I'll show you a very minimal deployment of OpenStack, and then I'll also show off some of the SRIOB stuff as well. So the first thing I want to look at is the minimal version of OpenStack, which is just this one compute node, and you see he has exactly one NIC for provisioning and one NIC for SRIOB, so we can do VLAN tagging. And the same thing for my controller. Will be true. So let's log into this guy. I'll have a look at him.
You make that one bigger too?
Yes, I'm definitely going to make that one bigger. I just want to get logged in here. This one I can definitely zoom in on. Where is bigger? Is this legible yet?
Mm-hmm.
All right. I'll promise I won't play around in the terminal too much. I know that that's a little boring for everybody. But let's start by just taking a quick look at Nova List. We'll be able to see there's probably nothing. There's going to be definitely nothing running in here. We'll look at hypervisor list. We should see just the one node, the one hypervisor. And let's just jump into one of these guys, and we'll have a quick peek around at some of the things that are going on in here. So a quick look at LSPCI will show us that we have an Ethernet controller from Red Hat, the VirtIO one. But if we go and look at LSPCI-V, we should also see that we'll have a virtual function, this guy right here. So this is the actual virtual function that is passed through to the host. So what is this all about? Why a virtual function, and what is it doing for me? Well, we have something called the VLAN overlap issue. The original implementation of virtualized control plane, which let me get back into rep so I can kind of show you a little bit more about that. So originally, the virtualized control plane was kind of a dry thing. You would come into your networks, and you would make a network for every OpenStack network that you wanted to deploy with a VLAN. So you would come in here, you would make a provisioning network or a Pixie network, an internal API network, an external API network, a storage network, a storage management network. And then you would tie all these to your OpenStack in the way that would be a single NIC per VLAN style NIC config. The problem with this is that when you use controllers, or controllers in general, when you want to do something like, say, what do you call it? What's the right term for extra network that's on? Not a tenant network.
Overlay?
No, not the overlay. When you add in a new VLAN and a new network for new trunk. Not a
Trunk?
Why am I losing my mind here? A provider network. If you want to do a provider network, you create a new, like you're spawning up a new VLAN tag, but now your controller is going to have another NIC automatically attached to it with that VLAN tag automatically happen. Right? You're going to have some way for that controller to speak on that new VLAN that just came up. So what happens is that there's no trunk port exposed. There's no way for it to spin up a new tag. This leads to what we call the VLAN overlap problem, because you can expose a trunk in OVirt to a guest by turning off all the network filters. But what ends up happening is because OVirt's doing the filtering, things that are tagged that it controls in its logical network and things that are on the trunk can't pass the traffic between each other on the same NIC. If you add another NIC, you could send the traffic out one side into the switch and back, and that would be fine. But when it all occurs on the same card, it kind of doesn't work. It's called the VLAN overlap problem. So SRIV gets around this because it just completely drops out and hits the switch. It's literally taking a slice of a network card and handing it to the instance. It's pretty sweet. This also allows us to do things like model things with bonds with VLANs and other more complex NIC configs that you would want to do with OpenStack. That's more or less what you would look at. If you are trying to model a more production deployment, they're probably going to have a raft of NIC cards in their machines, and they're going to want to segregate storage from their tenant traffic, and then from their control plane, and then maybe they even want a management network on top of that. And this will allow you to provide those networks and those bonds to the virtual machines to model that.
Hey, Paul?
Yep.
Could you also pass through the NIC itself and do things like DK or something?
You know, that's honestly, I was just having that thought. I was like, on my way over here, I was thinking, I got to talk to Joe and ask him, like, what are the most dirt cheap network cards that I could get to toss in there? Because I don't want to buy, again, not smart nor money, I don't want to buy more expensive equipment that I don't have to. But that was the other thing. It's like, how can we take this further? How can we make these virtual machines more like real machines to model what we do in the real world? That's what this is entirely about, or at least what I'm trying to do here at home for fun and for sadness sometimes, as things don't work or they didn't work. All right, so again, the VLAN overlap problem exists. It's a real thing. I wrote about it. I should probably have put a link up to that, but no matter. SRIOV is one of the ways around it. Aside from just having an additional NIC in your host to be able to segregate the traffic out, doing SRIOV is a great way around that. And again, it's a little bit more elegant. When you do SRIOV like this way, I can just hand, again, just a regular trunk port to my machine and let it do all the tagging. It's nice. It's a nice, easy way to go about that. So we looked at the small OpenStack, and let's just take a look at one of the more interesting little demo setups that I have here of a bond happening between SRIOV, because that's one of the more interesting bits. Now, the unfortunate part is SRIOV right now inside of Rev is constrained in that we only really have one bonding mode that we support in that, and that's just active. That's just active backup, which for the most part is fine because the default bond with VLANs is active backup, so those things right out of the box will work. And I believe I have an SRIOV demo right here. We're just gonna run the console because we're feeling cheap and we don't want to type again. And here's where my demo just blows up right in my face. All right, it looks like we're going to be going into the term. He is 7235.
You make it no bigger?
Yep. So we can see here are our two virtual functions. We will cat procnet bonding, bond 0. We see that I have my two virtual functions in a bond. They're nice and slaved up. I SSH into this machine over this bond, so we know it works for sure. So again, like these are ways that we're trying to model real hardware in OpenStack, and I think that's more or less what I have for a demo, like without going completely nuts. If I had like an hour or two, go ahead.
If you pass through the physical NICs as well, can you also do like LACP-based bonds?
Yeah, more than likely. That like again though, that's maybe like round 3 or 4. Like I definitely want to get there though. Like this has all been an experiment to build up to be able to do these kinds of things and be able to model bigger and better deployments.
But theoretically, you should be able to, right? Like
Theoretically, yes. Like theoretically, you can pass through almost any PCI device. Sometimes they require some drivers to be, even if they don't exist. Like for instance, oVirt and Rev right now will already do PCI pass-through of GPUs and other things. And in fact, NVIDIA Grid has a virtual GPU pass-through for Rev. Just like SRIOV, which breaks apart a NIC card into individual functions that you can give away to instances, this will do the same thing for a GPU, so that you could do like other like GPU grid style workloads. So let's go back to our slides. I want to enter presentation. So yeah, that was definitely more oVirt than OpenStack, and you know, I'm sorry. So because of that, let me go back to the start. Modeling anything in oVirt. Thank you. Any questions? Go right ahead.
How do you decide on your core to RAM ratio
For OpenStack,
for your lab?
It was more like, what could I afford on eBay?
How much is a 160 core drive?
Well, it's comprised of 4 machines, and at the time that I bought them, it was $1,000 a piece.
$1,000 a piece?
Yes,
That's it?
yes.
Huh.
Well, it's 160 core spool, right? It's only 40 a box.
Only 40 a box.
Yeah, only 40 a box. Gen 7s and 8s are about that price. You could buy them completely shucked for maybe about $300-400, and you can supply your own parts, like CPUs and RAM. But I don't suggest that. The RAM gets expensive, and there's tons of little sticks in those things.
I made a home lab last year. It's a little off topic, but I made a home lab last year. 220 gigs, 12 cores for $1,200.
That's not bad. I mean, like, okay, let me explain. That thing just didn't pop in out of nowhere overnight. I started with a bunch of like little PC boxes that were all built off of like MSI gaming motherboards. This started with the dream of just Rev and InfiniBand. Back when InfiniBand gear on eBay was super cheap, you could find like the 10 gig top switches and stuff like that for just a couple $100. It was all like really decommissioned at that point. And Rev had like bare support for it. The idea being that we could get a bunch of Barracuda 2 terabyte drives, jam them in a box with a RAID card, and then use InfiniBand to feed it to the VM so the VMs weren't completely sluggish, right? In order to be able to have shared storage. Lustre wasn't exactly the best choice there either because we only had 2 nodes. We went through a lot of pains and failures before we added in another node that stood in that would just host our bricks, which saved us the expense of building another complete storage node to form the forum, but now we're much more stable. Taking away InfiniBand as well led to a lot of stability in the lab because upgrades would break InfiniBand all the time, and so this was a long time coming. So this was me more again loading up the clip and firing off at eBay again and trying to bring home the 10 gig to replace the InfiniBand. Anybody else have a question? Go ahead.
What's your stand-up and tear-down procedure for your controller and your compute? Are you using like an Ansible oVirt module, or how are you automating your build?
Oh, so that the builds are all being done by OSP Director. Are you familiar with OOO by any chance?
Yes.
Yes. Okay, so last year, upstream, well, not last year, but in OSP 13 or RDO, we released an oVirt driver that allows you to manipulate the power state like an IPMI driver for Ironic. And that's the real magic behind all this. I'm straight up abusing the thing to do things that it really wasn't intended to do, which is like provide bare metal targets, virtual machines as bare metal targets for Ironic, building compute nodes. They really only wanted you to do your controllers and to leave it at that. Which, granted, if you're running something production, that's probably where I'd leave it too, as far as running things that users will use on a daily basis. But it also begs the question, I have all these additional virtual resources, why don't I build a little mini stack of my deployed stack in it so that I can test stuff before I test stuff? A little bit of exhibit there. Anyone else? All right.
So you mentioned there's you mentioned some benefits of modeling the OpenStack in your lab. You've been working with some clients that probably virtualized controllers. What do you think are the biggest benefits of doing that in production?
The biggest benefits of doing that in production, aside from the reduced footprint, is being able to snapshot your controllers. As far as enterprise goes, being able to snapshot, roll back your controllers, recover from that kind of things makes recovery from failure a lot easier. In general, when you do that, if you can recover your controllers, and then you can generally rebuild any compute instance that you want and not have any bad effects. It allows for a lot more flexibility. It also allows me to, again, roll back changes, have backups, have snapshots, especially the Director 2. Like if you are going to go through an upgrade procedure, it's just peace of mind of just going and snapshotting all those guys before you run it just has tremendous benefit to me. But as far as being able to develop templates, like having something run until it breaks, instead of having to stop and tear down everything, if I just revert, shut everything down and bring it back from the snapshot, I can be up and running and trying my test again with a new set of configs a lot quicker than it would be to stop, delete the stack, wait, clean the nodes, all that stuff. which is the general iteration cycle you make when you're trying to test new templates and stuff.
Any benefits from the scale-out perspective?
You can also test scaling, and as well as if you find that your scaling is going slow, being able to virtually assign resources to things like the director can help your scales considerably. For instance, in OSP 14, the director requires a bit more RAM. Being able to just add that onto your machine and try to alleviate some problems that it's having, or some slowness and timeouts, can go a long way towards that.
Yeah,
So as well, like I should also mention, like we already do the virtualized control plane. We already put controllers on there. Being able to take advantage of maybe SRILB would definitely make the controllers faster from a network perspective, or make them more responsive. You can also engage NUMA and pinning and all the normal accoutrement that you would have for tuning a VM inside of OpenStack. Well, okay, let me take that back. OpenStack can do a bit more than oVirt will ever probably be able to do. But in terms of that, like pinning cores and pinning resources, that can also help make your virtual controllers a bit faster and a bit closer to the hardware that they were intended.
any drawbacks from running controllers with virtualized? Is there anything we should be worried about?
The only real drawback to that is that it'll consume a bit more resources in terms of storage. You'll have to pony up some shared storage to get Rev up and going. Aside from that, I think that there aren't many drawbacks beyond that I can think of at the moment.
How well did aggregate sharing work? What did you do now?
To be honest with you, my hosts have so much RAM, I haven't really thought about that. That's an embarrassment of riches problem, you know. All right, so I think that's going to be it.